All right. Good evening, everybody. Hey, Chris, how are you doing today? MJ, good to see you. All right. Well, the Twitch stream has gotten a little bit of attention on Twitter for the past couple of days. I've been talking a little bit about my adventures with F Sharp. And so I'm hoping to go ahead and pick some of that up again tonight. I can't remember if it was Icarus or Rook on our last stream who recommended this book, Domain Modeling Made Functional, by Scott Walshin, the same developer who authored F Sharp for funandprofit.com. And I only had about 20 minutes to go through some of this today while I was grilling some steaks on the barbecue for dinner. I've been doing a lot of CEOing this week and not nearly as much coding. You got your 5G chip today. Does that mean you got your COVID vaccine? H3, good to see you here for Scotch and Tequila and maybe some F Sharp. I am breaking out some very tasty bourbon tonight. So this is Smoke Wagon. It is a Las Vegas-based distillery. And Angry Bird, good to see you. Smoke Wagon's a Las Vegas-based distillery, but all of this bourbon is actually distilled in Indiana. It's an MGPI product, similar to Bullet Bourbon and Angel's Envy and a bunch of other products. But these guys make a great bourbon. I've had some of this before, and I've also had their barrel strength version, which is really good. So I'm gonna go ahead and pour a little bit out and lubricate the old brain here as we get started. Doing a little bit of F Sharp domain modeling tonight. Nelson, good to see you. All right, we got a crowd tonight. That's excellent. All right, so that's Indiana corn juice that I'm drinking here, this whiskey. That is very nice. It's got a lot of caramel, a lot of oat, only a tiny amount of spice, not as spicy as some of the other ones I've had lately. And just a few hints of rye. Man, that's good. But yeah, this is whiskey is just corn juice for the most part. Although a little bit of rye mixed in there, and sometimes other grains like malted barley and wheat will make it in there too. But it's mostly corn. All right. Now, I haven't had much of a chance to play around with some of the F Sharp bits I've been working on. So I'm delighted to try to get back into some of that tonight. On our last stream, I believe we were working on, let's see, I built some of this out, our user activity record, which is basically meant to go ahead and kind of be a somewhat generic object here. Let's see. User activity record, this has all the user identity, IP address, timestamp information. And then we have this generic user activity event. We had already kind of built the C# equivalent of all this a couple, I'd say probably 3 or 4 episodes ago. We've ported this to F#. So I believe we were working on, if I can go ahead and find it. Let's see. This is the file system. Let me switch to solution view. That's a little bit cleaner. So I think I was just starting to work on trying to go ahead and define product state. And in fact, I believe I had, let's see, I think I had another version of the Sdkbin code. Let me go ahead and pull this over to the side here. I think I had my old C# version in a separate folder, and I was kind of working on porting some of that. Now, I want to talk a little bit about Scott Walshin's book. So those of you who are already experienced F# programmers, you will still get some value out of domain modeling made functional, because Scott's approach to thinking about bounded contexts and some of the more domain-driven design facets of this book are still very relevant, even if you're an experienced functional programmer. This functional programming is more of a, methodology for how you go about implementing these ideas. What this book is largely kind of focused on is how you cleanly separate the different facets of your domain and design well-typed constructs for those different parts of your domain to interact together. And they talk about so much of the various domain-driven design models, such as the shared kernel pattern, where two different domains that interdepend on each other both kind of own the communication contracts. And they've also talked about producer-owned contracts and consumer-owned contracts. And so we're going to go ahead and probably get a little bit more prescriptive with the way we're thinking about modeling our domains in this application here. Since so far, I've just been kind of shooting from the hip on a lot of it. So might not be a bad idea to go ahead and try to harden and sort of make things a little bit more robust there. So let me see if I can go ahead and pull up my other Sdkbin code here. Let's see. Yep, I think I've got it. Okay, so I went ahead and downloaded a zip file of that C# branch I was working on. So let me go ahead and grab that. Go ahead and grab this. Yep. New window. All right, voila. Go ahead and move this off to the left here. All right, this is all of our good C# code that we were working on for this. Now I'm trying to remember where I left off last time I was doing some development on this. So let me go ahead and borrow my, excuse me. Let me go ahead and borrow GitHub for Windows here and take a quick look at my history. What was I working on? So we added some structured types for being able to do things like have types that basically require integers to obey certain rules. So in particular, we were building out some of our pricing data structures. And we wanted to go ahead and say, okay, for a recurring billing plan, the period has to be greater than 0. Otherwise, it's not recurring by definition. So we want to go ahead and guarantee that at a type level. So we did some of that. And then we started drafting some discriminated unions for talking about what state a product's in. Okay, this is all coming back to me now. So we're working on the product data type, which is where we're learning to working on going and defining things like the product terms and some of the other various constructs we'll need to build this application. Okay, and sure enough, this is the file I've got open. All right, so we'll go ahead and pick up where we left off here. Man, that smoke wagon is good. That stuff's kind of hard to find, though. It's not expensive, but you just don't see it all that often. So this is in products.abstractions. Let me go ahead and grab some of my original C# stuff here. Let's see. Okay, so my original C# data, I'm just kind of moving my windows over. I had my product display data, which was this big old, this is what we're trying to avoid in this type. This was a big old complex type with a whole bunch of optional little bits here. And the reason why we had this is we were trying to go ahead and create a, basically like a messaging format where I only needed to specify one of these when I'm in the process of trying to send an update over the wire. This turned out to be a very cumbersome way of trying to go about doing that. So we're probably better off with something like I don't know. There's probably a better pattern for combining all the different types of data we might want to go ahead and send back and forth over the wire here. But what I was trying to avoid also is having an explosion of like a huge number of different events. Maybe that is unavoidable. Maybe we have to go ahead and do that. Maybe it's better for us to go ahead and have really granular events that basically allow us to only update one of these types of properties at any given time. And we'll just have to go ahead and persist more of them. And that way we can go ahead and avoid having this big explosion in our wire format. In fact, that's probably actually a better way of going about doing this. So I think I just finished defining in F# my product terms. I think I had done, instead of doing an enum, I did a discriminated union for this. I'm not sure if that's the best way to do it in F#. I basically created a discriminated union where I don't actually have any implementation types. I just wanted to say like this enum has to be in one of these 3 states. So hopefully I did that right. Maybe I didn't. We'll find out. And then I think I finished defining my product kinds. Product kinds are basically meant to be a hint to the fulfillment engine how do we actually go and deliver this product to this end user? So right now, Sdkbin is very focused on NuGet. So when a customer buys a product on Sdkbin, we go ahead and generate a brand new, what's called a proxy NuGet feed for that customer. That's a unique set of NuGet credentials that are basically made available for just that one customer. Those NuGet credentials basically mirror the packages that are published by the owner of that product on Sdkbin. And so the end user never actually sees the real underlying routes where any of those packages are served. It's all done through a proxy web API that is managed by the Sdkbin team. Oh, whoops, didn't mean to do that. So that's kind of how we're doing things right now. But obviously, we are going to want to expand this to include different fulfillment types. Probably the next one that we're going to add support for is actually customer support plans, which the billing for those is a bit different. Those tend to be utilization based, where a customer buys a preset number of either issues or incidents, or maybe they buy a preset number of hours. That's how we do it at Petabridge. Our support plans actually sell a bank of engineering time that you can use on as many different issues as you want. And that engineering time goes towards, like, I'll give you an example. We had a customer that basically needed to have us add clustering support to our Aqueduct Persistence Redis plugin. That took about 16 hours of engineering time, so 2 days full time for one of the members of the Petabridge team to go and implement that. But that solved the major problem for that customer. And we were able to go ahead and do that within like a week of them asking us to do it. So that's what you get when you get a support plan. The fulfillment for those basically requires us to go ahead and issue reports to users on here's what your hours went towards. And you got to see kind of an accounting record for how those are spent down over time. That's a very different type of, let's say, fulfillment and billing experience than, let's say, a licensed product like Phobos, where you pay a flat rate on an annual basis for getting it. Sdkbin needs to be able to support both types. So we want to go ahead and have within our domain around fulfillment here the ability to kind of describe the different possible fulfillment types. And I think I actually already did this in F#. If I go to kinds, yeah, here we go. So I basically created a bunch of singletons in F# here. So I created my product kind interface, which is just a marker interface here. That's for serialization purposes. I have a NuGet product, which has a private constructor. We go ahead and we create instance here. We do this for support plans. And then I have a package of type, a package manager product. We can assume that NuGet, NPM, Maven, traits, if we ever add support for Rust or any of that sort of stuff, we can assume they would all have a fairly similar billing and delivery mechanism. Likewise, if we go ahead and offer service products, support's probably going to be the most common one, but we might also want to add in the future for people to have the ability to go and do things like sell, I don't know, a fixed price package. Let's say Sdkbin gets bigger than just software developers. Imagine if you have a graphic artist that wants to go ahead and do work on Sdkbin. Maybe they have a package that costs a few $100s for doing some logo or branding work. You'd want to go ahead and have the ability for them to sell that as a service on the platform too. So we're trying to just kind of, we're not trying to exhaustively cover every possible thing we might ever do in the future on here, because that's kind of, it's not Yagni, you ain't gonna need it, but you're not gonna need it now. It's probably a better way of putting it. So we're just trying to go ahead and build a system that can be extended to go and support these new types in the future. And we want that to be fairly painless. So now one thing I have to admit, I don't know if it's a breaking change in F# to add a new type to this discriminated union in the future. I am hoping it's like extend only design, but that's not actually a binary incompatible change. I could be wrong, but we'll see. However, we're going to end up eventually decoupling from a serialization point of view. We're not going to use polymorphic serialization to serialize these objects to store them in Aqueduct Persistence, or we're not going to send them over the wire using Aqueduct Remote as is. Reason being is that for those reasons I just mentioned, namely binary compatibility and version tolerance, polymorphic serialization is really dangerous. It's very easy to introduce breaking changes you don't even know about. And the impact of that can be things like not being able to read any of your stored data. And that's really bad. So we're going to go ahead and essentially separate our concerns. We're going to separate our wire format from the way data is represented inside our domain. And we're going to use probably Google Protocol buffers to help represent some of that. So I can make that version tolerant independently of this model. But I'm just saying, due to my lack of knowledge about F#, I'm not actually sure if extending a discriminated union with a new type ends up essentially changing the binary signature or not. With C#, I can answer all those sorts of binary compatibility questions just from years of managing the Akka.NET Projects API. F#, I'm a babe in the woods, so to speak. So now that's kind of probably enough build up for now. Let's go ahead and work on trying to go ahead and build up some of our domain types. Now, one thing that might be kind of useful here is maybe going and specking out real fast. Let's see, how do I do a block comment in F#? Is this how you do it? Yeah, okay, that's how you do it. All right. So, product state begins uninitialized builder state. Eventually, as a user adds pricing plans, license terms, product kinds, etc., the state transitions. So first we have uninitialized. Hopefully I'm spelling that right. Uninitialized. Gosh. Let's see. All right. Replace with. All right. There we go. Well, apparently I was not a spelling bee champion as a kid. Either that, or I've just become way too dependent on type check or spell checkers. We have uninitialized. Then the next state is basically go ahead and receive set product kind command. In fact, I'm going to go ahead and say receive create product command. It's going to go ahead and produce uninitialized product state. So I'll go ahead and describe this input. We'll go ahead and try to describe this like that. Output. And we'll go ahead and say uninitialized to created. I'll go ahead and express my output as a state transition. I think that's probably the best way to think about it. I'm going to try to model these domain objects as state machines. That's kind of a natural way of thinking about doing workflow processing. Particularly when you're doing, let's say, a large number of different concurrent entities that might be updated. You think of each entity as owning its own little state machine. And what we want to try to do in F# is make it impossible to represent an illegal state. That's where we're going to try to go with this. So what I'm trying to spec out right now is basically, init uninitialized. Basically trying to spec out, oh my gosh, I really cannot spell that. I haven't even had more than 2 sips of my bourbon yet, man. All right, so in this stage, we're in the created state. Actually, you know what? I'll do this. State initialized, state created. In the created state, we're going to do receive set kind command. Output, we're going to do created kind set. Then when I'm in the state kind set, by the way, the assumption is any events that are not, any commands other than these ones, we basically can't really process. So we're going to go ahead and either buffer those or reject them outright. I'm probably going to go ahead and reject those because it should be illegal for our UI to even send them in this state. So if I go ahead and receive, we'll go ahead and say receive, I don't know, set product data command. And I'll go ahead and put basically between 1 to n on here. Then I'll go ahead and do receive set price plan 1 to n command. And I'll go ahead and say outputs. If let's see, all data set, then created. Oh, I say kind set ready to publish. Although actually, you know what? I'll go ahead and do this. Output of all these states will basically go ahead and be kind set. We won't go ahead and change the state machine. However, when we're in state kind set, and I go ahead and receive publish product command, and I'll go ahead and say, when all product data set was true, output kind set published. When all product data set false, output and finally, when we are in state published, I'm going to receive, I don't know, any of these. We'll go ahead and stay in our little published state. People can go, there's some types of state transitions that are illegal for, actually, you know what? There's another state I'm missing. Dang. I need to be able to also go ahead and receive start fulfillment request command, receive complete fulfillment request. So fulfillment request would be something like if after you set the kind on your product, you go ahead and get a notification from Sdkbin like, great, here's your publisher credentials for NuGet. You need to upload at least one NuGet package here. When you've uploaded at least one NuGet package, the actors in the fulfillment domain will send us a complete fulfillment request. We'll consider that fulfillment request to be satisfied at that point. However, if you haven't published any NuGet packages, you can't sell a product that is offering those to people. Likewise, if we're offering for support plan sales, integrations with platforms like Freshdesk or Zendesk, you have to actually successfully integrate with Freshdesk or Zendesk from Sdkbin. Otherwise, we can't sell a product. These are things we need to do to protect the consumers. We need to make sure they're not buying vaporware. So that's going to be kind of a bare minimum part of our publication process. So we're basically adding some more kind of like guardrails in here before we allow people to publish products. By the way, another thing I could potentially do when someone tries to publish a product down here, I can go ahead and require that an Sdkbin employee has reviewed this product and published it. I can go ahead and add that to the state later if I want. So that's something else we can go ahead and add if need be. Okay. Now, when we're in a published state, we'll go ahead and stay there. However, if we're in a published state and we go ahead and receive an archive product command, this means that this company no longer wants to offer this product for whatever reason. Then we'll go ahead and do published archived, which means no new customers can buy it, and it'll probably wind itself down after renewals. So it'll probably go ahead and gradually deprecate itself. All right. So I think we've done a pretty reasonable job of trying to kind of capture some of the communication contracts and events here. This makes me feel good about some of that, but we're going to go ahead and need to build some data structures that can capture this. So let's see. So I've got my product terms. I've got my pricing data structures. We went ahead and we created all that jazz. That looks good. We have our wrapped integer construct there. Product data looks good. What else do I need? Okay. I've got my display data. Okay, so I should probably go ahead and define some of this. Let's go ahead and add this to our product data. All right. Product terms are kind of their own thing. You know what? I'll go ahead and add. Do I want to add another little marker interface in here someplace? I don't have to. I guess I could do a discriminated union for this. All right, I'll do a discriminated union. That's how I'll, rather than a marker interface. All right. Let's go ahead and do type. Let's see. I need to go ahead and add. No, I guess that's all kind of defined there. That's all somewhat defined. Let's see. Type. Okay. And do I have things like websites defined up in display? Title, string, I do. Okay. Well, I should be okay then. Okay, I should actually have enough data to go ahead and define my discriminated union. Okay, so we'll go ahead and call this product display data. And this is going to go ahead and be a union of, let's see, terms of product terms. We'll go ahead and have, let's see, what else do I need to go ahead and do this? I'll go ahead and do description of, let's see, display text. I'll go ahead and do a tagline of display text. And let's see. Hey, Rook. Good to see you. I don't know if Brooke, it might have been you who recommended this, but I found my copy of Domain Modeling Made Functional. Didn't get a chance to go through it in as much detail as I hoped I would today, but man, that book is fantastic. I want to spend some time reading it, but unfortunately, I have been stuck in PowerPoint for most of the past 4 days here, doing a lot of roadmap, executive, CEO stuff, which is not as glamorous as it sounds, not even a little bit. But that's what I've been up to. Thankfully, I think I'm out of the woods on a lot of that for now. Okay, let me go ahead and do a split screen here for a second. I want to go ahead and add, let's see, yeah, we'll call this like a screenshot of a screenshot. Is that legal? I think it is. Yeah, I think it should be fine. We'll go ahead and do logo of stored file. We will go ahead and do, yeah, website. And then finally, let's see, I think that's everything I need for now. So when we want to go ahead and push, represents a unit of display data for a product. Products typically need at least one of each of these types. Okay, there we go. So that discriminated union is what we can use in our protocol for trying to go ahead and update the display data of our little product state we're going to go ahead and work on behind the scenes here. So that looks good for the time being. That's better than a marker interface, in my humble opinion. And so I need to go ahead and let's see, take a look. Product published status, got that. Okay, that looks all right. Draft published archive, that looks good. Product terms, price plan, product kind. Okay, everything looks like it's pretty well defined now. I'm gonna go ahead and say product display data finalized. Go ahead and commit that. Move that over to the right here. All right, up. Didn't type my GPG password in. By the way, GPG signing is something I recommend. If you work on open source or really anything on GitHub, I strongly encourage you to get GPG signing set up for your Git client. Reason why I like it is if I go to, let's see, this is the Aki.NET project, right? Yeah, it is. So if I go to the Aki.NET project, and I go ahead and take a look at our commits, you can go ahead and see, at least I thought you could. Oh, here we go. Yeah, I was looking in the wrong spot. Derp. You can see these commits are verified. And that basically means that these commits came from someone who's got GPG signing enabled. So like Dependabot built into GitHub has it. I've got it. And then Gregorius and our team here at Petabridge, Ishmael, and Zenonova, these are all experienced contributors in Akka.net. I think they've all got GPG signing set up. Just kind of allows you to make sure that the person who committed this code is who it says it was. It's kind of useful for the proving the veracity of where your, or not the veracity, sorry, the provenance of where your code came from. So we do this so we can just go ahead and show our customers, oh yeah, like we know, you know, here's all these commits to these performance critical areas, and you can tell that it really came from me by taking a look at this. So that's something I strongly encourage everyone to do if you do a lot of work on GitHub. It can be very useful, particularly if you need to go and prove to someone else you actually did something, or if you want to go ahead and prove that all the commits that are in this code base came from one organization. GPG can be really helpful for that. Plus, you get that nice little verified check mark, which makes me feel good when I'm doing programming on GitHub. All right, so I think we've got the gist of our base types. Now we need to figure out how to model our states. So this is where using some of Scott Walsham's wisdom would be very helpful. So in particular, the advice we want to try to implement, let me find it. That's not it. There we go. Making illegal states unrepresentable. That's something that we want to try to accomplish here. All right, so legal states include a product that is not yet in a published state here. So one of the things I've kind of got to be a little mindful of is the way I've spec'd all this out right now is I've spec'd this out in such a way where it's like, okay, my state for trying to go ahead and build my product state is basically kind of relies on a bit of a builder pattern. Now, the reason why is like this isn't quite the same story as submitting an order through a website or like with one of the examples of Scott Walsham's book. This is more like I have a big builder interface, and it might take me hours or days or weeks to go ahead and get all my data ready to go and publish a product. I need to go ahead and make sure that I save and preserve those incremental states along the way as I go and build it. Because this data just takes a while to build. Getting your description right, getting all the right product screenshots, getting the license terms right, all that stuff takes a little while. Even if you already have a lot of that stuff in the can, like how we do, it can take a little while to build that up. So that's something that we want to be a little mindful of in how we model this. So I'm thinking that our product state is going to essentially be an aggregation of a number of different underlying types downstream here. So the way that Scott went ahead and made, let's say like these, content only has an email address, only has a postal address, or content has both. The way he represented this was with a discriminated union, which includes some tuple types and some other single cases that involve records. Well, in our case, that may not quite be enough to go ahead and get the job done. So let's go ahead and think about this for just a second. And think of the different components that are going to comprise a product state. So let's go ahead and do a type. And we'll go ahead and call this our, just thinking out loud here. Want to go ahead and build everything up. We'll go ahead and say type. Product display state. And we will go ahead and have, if I can think this through, you know what? Let's go ahead and do this. Complete display state. Well, complete display state, maybe it's, So for any of the F# people who are attending today, is it a bad practice to have a tuple that has like several different types built into it? Like if I had a tuple with 8 types in it, is that considered to be a bad practice? Is there a limit on the number of types that I should include in a tuple? That way I could avoid having to compose a whole bunch of additional record types if I can get away with that. I'm thinking of like sum types is kind of what I'm considering here. So let's see. Well, one thing I can go ahead and do is I can force the publisher to have to go ahead and initially populate things in a particular order. That's something I could do. Let's see, what's the best way to go ahead and model this? So I want to eventually get to a completed state where we have everything. Question. Hey Aaron, is it possible for Aquanaut cluster to join another Aquanaut cluster as a single node? Sort of like recursion. No, it is not, because the Aquanaut cluster state, basically we only allow you to kind of be a participant in a single cluster. One thing we will be adding support for is what's known as multi-data center Aquanaut cluster, where you can have different, let's say, topologies that exist within their own data center. And those nodes all basically share a very high degree of affinity with each other, meaning they tend to prefer communicating with each other versus nodes that might be in a different data center. And that's because there's usually real latencies involved in cross data center communication, whereas the communication between nodes within the same data center is usually all confined to local network interfaces. So a virtual, let's say a subnet that exists within one availability zone on Azure, or one subnet within one, let's say, I guess it would be an AZ in AWS, an availability zone there as well. So we don't really allow that. We do allow you to go ahead and connect to a node in another cluster via Aquanaut Remote, though. You just can't be a member of more than one cluster. That's something that Aquanaut Cluster does not allow. So maybe what I need here is a builder pattern in F#. That's kind of where this is going, I think. So how would I do a builder pattern in F#? Implementing a builder, 0 in yield. Well, Scott Walshin's got us covered once again. We go ahead and pull this up. All right. Builder types. Wrapped and unwrapped types. Let's see. Okay. Yeah, no problem, Rook. All right. I don't know what a computation expression is. All right, implementing a builder, 0 in yield. Let x equals some tuple, and then, I guess this is a binding expression, is what that is. This is pattern expression definitions. Implementing special methods in the builder class. Okay, here we go. Diving in, creating a manual implementation of a workflow. Going with a builder pattern probably seems like a better idea than trying to go ahead and define all these comprehensive states and transition between those. Now, one thing I don't know is I actually don't really know what binding is in F#. That is totally new to me. So that'll be something we'll have to figure out tonight. So I'll take a look at that. And if anyone wants to tell me what that is as I'm going through and chat here, by all means, please go right ahead. Let's see. All right. Creating a minimal implementation of a workflow. We'll be creating a minimal implementation of the maybe workflow, which we'll rename as trace, with every method instrumented so we can see what's going on. Okay. So we call this .bind and F, match M with none, binding none, exiting some, binding with some, continuing. We return option.bind. Okay. Well, let me go ahead and look that up. F# option bind. Okay. Man, this guy does not miss. Okay, introducing bind. In the last post, somehow we can think of let as a nice syntax for doing continuations behind the scenes. And we introduced the pipe into function that allowed us to add hooks into the continuation pipeline. Now we're ready to look at our first builder method, bind, which formalizes this approach and is the core of any computation expression. All right. So documentation, let pattern equals expression in expression equals 43 in some expression. Notice a few interesting things about this. Bind takes two parameters, an expression and a lambda. Parameter of the lambda x is bound to the expression passed in as the first parameter. In this case, at least, more or less later. Parameters are bind or reversed in the order they are let in. So in other words, if we chain a number of let expressions together like this, the compiler converts the calls to bind. Bind 1 equals function. So what is this? Am I basically going and binding a function or expression to a symbol here? Is that what this is? So I can just reuse that symbol on the fly? Is that what's going on? Let's see. Having a bind function like this is actually a standard functional pattern and is not dependent on computation expressions at all. First, why is it called bind? Well, as we've seen, feeding an input value to a function. This is known as binding a value to the parameter of the function. Recall that all functions only have one parameter. Yeah, that's the currying stuff. Right. Got it. So when you think of bind this way, you can think of it similar to piping or composition. In fact, you can turn it into an infix operation like this. Okay. Divide by workflow. So this is basically what just piping the output along the way here. First, the bind function has extra customized behavior for extra situations, not generic like a pipe or composition. Let's see, let pipe into match. This may be builder. This might be a little bit beyond me in terms of this stuff. The option.bind syntax, this seems a little like this isn't totally clicking for me just yet. I probably need to go, okay, exercise. How well do you understand? All right, not very much. H3, I'm glad we're not alone. Thank you. This is absolutely hurting my brain too. Okay, first, let's create a function that parses a string into an int. Okay, well, you know what? This will be a good time for us to go ahead and create a new Scratch file. And I think I could do this in F#. Yeah, let's do an F# script. All right, Scratch to FSX. Let me go ahead and get rid of that. And I'll move that over here. That over here. And you know what? Let's go ahead and make this full screen-ish. Okay, how well do you understand? All right. Let's stir to int. Stir equals. And I assume that's not meant to be literally there. First, create a function that parses a string into an int. And then create your own computation expression builder class that you can use it in a workflow as shown below. Parses a string into an int. All right, well, I'll go ahead and do parses a string into an int. Right, let's try parse. Okay. Go ahead and do open system. Or actually, there's just a straight up parse. Yeah, there we go. That should get the job done. All right. And now, yeah, let's go ahead and do a little bit of muscle memory. String add workflow. Let's see. Create your own computation expression builder class so you can use it in the workflows below. I guess I need to go and define this. Okay. Let's see. My own expression builder workflow. Divide by workflow. This is hurting my brain too. Holy shit. Okay. Let's see if I can figure this out. All right. So my little workflow needs to be able to go ahead and handle 3 different little infix functions here that are going to add up all 3 of these integers at the end of the day. Okay. I think I can do that. All right. Okay. First, the original version. Next, our own version using bind. Uh-huh. If bottom equals 0. Okay. We go ahead and do, yeah, I guess I'll do if in 32. Try parse. Stir. And then I'm going to need to go ahead and add. I guess else. We'll go to return none. Is that right? Do I need to do a do or something up there? Oh. Then. Okay. Overloaded method try parse could not be a type annotation might be needed. Well, that's wonderful. All right, well, I'll go ahead and do. I think it's like what? Do I do a type annotation like this? 3. Unexpected argument. How do you do an out variable in F#? Try parse. Uh-huh. Let's see. Yeah, how do I do out? Nope. Unexpected argument. Argument S does not match. All right. How do we do an out variable in F#? Okay. So I guess I'll go ahead and do like this. To do like let let's see, shit. Do I go ahead and do what? And I like that. Or maybe get value key. Like this. Is that how this works? Oh, gosh. Yeah, all right, let's go ahead and try something a little different then. F#. Int try parse. How do I actually go and call this? Let's see. Oh, okay. Interesting. Found a good example of how to do this. Okay, let me give this a try. So we'll go ahead and do a match expression instead. Let I'm going to do true int int none. And I think that should do it. There's string. Yeah, that looks good. I think I need to add another type hint here, actually. Make this work. Int. I think. Oh. And what happens if I get rid of this? Seems to work okay. So apparently this is how you handle an out variable in F#. That is totally new to me. So, but still, yeah, got the job done. All right, well, let's keep going. So I need to go ahead and create, let's see, our own version of bind, this sort of pipe to stuff, all right? Let bind equals mf, option.bind fm. What does that even do? And then return with one of these. They want us to use a computation expression. Am I the only person when I'm taking a look at this? I actually don't see what the benefit of any of this is so far. Like, how does this really help with any of this? Oh, you know what? I'll withhold judgment here. All right. Let's go ahead and do type. Yeah. Maybe builder. Fine. Equals this stuff bind. Equals bind. Remember this return x. And then let's, what was the name of the workflow that Scott wanted? Sure, we'll go ahead and be real literal about it. New maybe builder. Okay, and so then I'll go ahead and do your workflow. Let's a equals stir to int x. B line. Add an extra space there. B. Return a B. C. Well, I guess I gotta tab it. Magic. All done. All right, we tabbed it all in. Great. So I guess we overloaded some operators here is what we did. In terms of the binding expression is, okay, so this allows me to go ahead and bind one of these functions to a symbol. Okay, I get that. And this allows me to go ahead and return some optional value here, I guess, based on the results of this expression. Is that what's going on? All right, well, let's give this a try. Value constructor string add workflow is not defined. Well, that is because I did not case it all properly. Okay. Well, let's go ahead and let's see. How do I run this in F# Interactive? Let's see. Yeah, sure. Why not? Hopefully that'll run. Okay, well, yeah, go figure. All right. I'm going to grab my little scratch here. Let's see. Tools. Terminal. Let's see. Let's see if there's some way I can just invoke this on the console. Inspect. See, I can go ahead and like select different little lines that run in F# Interactive. I see that prompt all the time, but when I actually want to go ahead and do it, it does not appear to work. Okay. Add. Tools. All right. Writer. Run F#. This is one thing Visual Studio actually would make easier. F# Interactive and Writer. As soon as F# Interactive is started, you can write F#. Let's see. Start a new F# Interactive section. See, select the block of code. All right. And do Control plus \. Well, lo and behold. So we got 17 back for good and then none for bad. All right. There we go. So my script ran. Hooray. Okay, well, that's helpful. Let's see. Clear all there. Now I'll go ahead and do reset. Fantastic. Okay. So I think I get the point of doing some of this. Designed to go ahead and allow multiple things to kind of be added to the workflow here. Understanding continuations, how let works behind the scenes. So if I want to go ahead and create this little builder pattern in F#, and one of the important things I kind of want to have is multiple divergent paths. I don't want to necessarily force the user to go ahead and have to get like everything published all in one go. Like I don't want to have to force the user to say, okay, you must add a description before you can add screenshots. And that type of thing. I kind of want them to be able to kind of go back and forth to some extent. You know what I can do? Maybe this is the simplest way of doing this. Is I can have an unvalidated object and then a validated one. And those unvalidated objects can be, in theory, they can essentially have no real data defined just yet. We can go ahead and have a whole bunch of empty types in theory. Let's see. Well, maybe not, because the way defining record types works is I would have to go ahead and have something inside each of those fields initially. So that'd be no good. So what if I don't have a website defined just yet? What if I don't have some of these other bits of data? That can be a little bit of a problem. Well, we can add some structure to the mix. Our structure could include a list of screenshots and a list of websites that we want to go ahead and add as material here, and that list can be empty for the time being. So that's something that we could do. Yeah, let me think about how I want to represent this. This was helpful for going and just kind of, I don't know, playing around a little bit with some of the, like F# workflow stuff. Implementing a builder, 0 in yield, combine, delay and run, overloading, adding laziness, the rest of the standard methods. I think it'd be worth going through this and doing the work on how we go about creating, let's say, a builder flow. I want to do this before I commit to actually going down one path or another, just so I don't have to go back and refactor all this stuff again later. And by the way, this is really important to kind of get right first, because we're probably going to be taking these same patterns and repeating them in a bunch of different areas of our domain. So we want to go ahead and do our due diligence and get it right the first time around. Therefore, when it comes time to go and implement them later in other parts of our domain, we're not reinventing the wheel each time. So I'm going to give that a shot. Before I give that a shot, I'm actually going to go ahead and take another shot of my smoke wagon. So I feel like after that, my brain kind of needs it. Maybe we'll hit the Balmer peak. Who knows? All right. Set that down there. Okay. Bottoms up. Okay, let's go ahead and take a look. So let's take a look at continuations and all this sort of good stuff. All right, Scott Walshin, take me through it. By popular request, it's time to talk about the mysteries of computation expressions, what they are, and how they can be used in practice. And I'll try to avoid using the forbidden M word. I'm assuming the M word is mutable. These words include the forbidden words. Monad. That's what the forbidden M word is. So Scott's trying to avoid all of the F# buzzwords that cause a lot of developers to freak out, like endofunctor, whatever the hell final coalgebra is, Jesus. Kelsey arrows, Curry-Howard correspondence, and worst of all, a 5-letter word beginning with M, that'd be monad. Repeated use of these words will result in banning. You will be exiled and forced to spend time with other incorrigible elements. It links to the Haskell website here. All right, let's go ahead and take a look at this. In this series, you'll learn what computation expressions are, how to make your own, and some common patterns involving them. This process will also look at continuations, the bind function, wrapper types, and more. Okay, fine. Computation expressions seem to have a reputation for being abstruse and difficult to understand. On the one hand, they're easy enough to use. Anyone who's written much F# code has certainly used the standard ones like C, Gray, Sync. But how do you make a new computation expression? Okay, I get this. So these are custom expressions you write that go ahead and write, basically, essentially via shorthand, go ahead and run a specific type of computation behind the scenes here, like being able to go ahead and essentially say this whole block's going to execute asynchronously here. Okay, that was not clear to me before. That's good to know. There seems to be some sort of mental bridge you have to cross. Once you're on the other side, it's all obvious, but to someone on this side, it is still baffling. I can sympathize with this. The actor model definitely kind of falls into this same pit too, where once you started getting used to thinking about modeling your state as, like, good example, a blog post I really should write about Akka.net is how blind write systems behave. So that's kind of the key to making a really efficient, large-scale Akka.net service. And blind write is not something that just strictly pertains to the actor model. Key value stores also tend to operate this way. And what a blind write system is basically there are no index scans in a blind write system. You go ahead and generate a natural key on the client's end, and that key gets used to go ahead and refer to a unique entity somewhere behind the scenes, and that entity either does exist or it does not, and you go ahead and you get, like the equivalent of a 404 back. We don't basically go ahead and do these sort of broad index scans for doing this type of stuff. And you can model a ton of really large-scale systems this way. Most analytic systems are built using blind write technologies, for instance. Video games, same deal. The real kind of places where you have to have things like index lookups tends to be when you don't know the identity of something you're looking for. So if you're searching for, let's say, through a product catalog, blind write systems not going to be very useful for that, because you've got to have some way of actually getting a frame of reference to the products you're interested in. And that requires, naturally, you actually need to have indices in order to do that. But when it comes time to do checkout and actually buy and fulfill a product, that's no longer true. You know the identity of the entity you want to interact with, and you can just go ahead and refer to that all the way down the stack from that point onward. So blind write systems are an example of like an actor, sort of a very common actor approach for how you go ahead and retrieve and create state. That is totally baffling to people who've never done it before. Most of us are so engrossed in database-driven development that getting away from that seems to just, it's like there has to be this kind of mental break away from the functionality of SQL lookups in order to actually go ahead and start using tools like the actor model or even decentralized key value store really well. So anyway, that was a bit of an aside, but I sympathize with what Scott's saying here. All right, for example, it says that when you see the following code within a computation expression, let pattern equal expression C expression, it's simply syntactic sugar for this call, builder.bind expression, and then here's the actual function that gets implemented. What does that mean? Yeah, you're exactly right, Rook. There's always some upfront, we'll go ahead and call it like intellectual overhead to kind of learning these concepts. And what you're really doing is you're basically fitting a new paradigm into your essentially like ways in which software can be conceived is what's going on. So learning a new syntax, learning a new programming language, that's actually fairly easy to do for the most part, because you're taking the same paradigms you have and using new tools to express them. Introducing a totally new paradigm to the way you think about software and architecture is much more expensive, because it's not the same as learning a new language. It's learning a new way of thinking about languages and software, and so that's you actually pay a much higher price for that, but the benefits you get are tremendous afterwards. Yeah, you're exactly right. Once you get past it, you can really go ahead and once you get past that cognitive overhead, you can really start leveraging these tools and you can really run with it. I'm still at the stage where I've got a very good, let's say, grasp on some functional concepts like pattern matching and currying and some of that sort of stuff. But these types of concepts here, like computation expressions and some of the workflows that Scott mentions throughout his book and on his website, these are still very new to me. And so I'm trying to make room for them in my sort of worldview here before I go ahead and begin reading and writing. Can I suggest to you another book that is really good? Yes, absolutely. I am all ears, always eager to learn. I can continue to go ahead and learn new things about programming every day, and I won't get tired of it. Okay. So, let's start with a simple example of a computation expression. Let log p equals print function. This is how you do print string. Functional programming in C#. That's the book you want to recommend. All right, let me look that one up real fast. Go. Functional programming in C#. I think this is the one from Manning that you're referring to. Is this the book that you're looking at? Okay, yes, this is it. All right. Well, let's see what they talk about in here. Function purity, designing function signatures and types. Arrow notation. Interesting. Structuring applications with function composition. Wow, they really let you kind of look at a lot of stuff up on the site. Here, I'll drop a link to this in chat for everybody. Average earnings over just quartile. Now, one criticism I'm generally going to throw at, so domain modeling made functional, so far at least, in terms of how much I've gone through it. And this, tend to assume linear, non-reentrant workflows for a lot of their examples. And those are usually pretty, in my humble opinion, those tend to occur in places where the entire workflow end-to-end can be executed in a very short period of time. Reentrant, let's say, not strongly ordered workflows, which happen very frequently in the real world, particularly for longer running processes, is basically what we're trying to model here. And that is a bit of a different animal in terms of how we go and represent that, which is why I'm going through the trouble of taking a look at computation expressions and builder patterns. The reentrancy part isn't necessarily, what the heck happened here? They intentionally scramble the text in order to make sure you go and buy a license to it. That's what's going on. Okay. I thought for a second this had switched to Cyrillic or something like that behind the scenes there. I got you. Well, I might go ahead and take a look at this book if that will help me kind of understand some of the patterns here. Stateful programs and stateful computations. Let's see. How do they suggest dealing with state? I wonder. Well, can't really tell. Looks like they're recommending in-process caching. Use actors, bro. That's the way you gotta go. But yeah, Brooke, I get your point. Learning the new paradigms with the same programming language I already used might be a better way of doing this. I appreciate the value in that. There's a great video on functional C#. H3, do you have a link to it? I'd be happy to share that in chat too. Actually, I think our permissions are pretty wide open on chat right now. You should be able to post the link yourself. If our Twitch stream audience continues to grow, I'll eventually have to restrict that. But so far, there's usually about half a dozen of us kind of just hanging out, and it hasn't been a problem. Okay, now where was I? Let me close that. Here we go. Computation expressions builder. Actually, no, this isn't it. Computation expressions introduction. All right. Computation expressions in practice. We go ahead and do let p equals print f, whatever. Log, log, log. Yep, got it. Simple enough. But it's annoying. It is annoying to have to explicitly write all the log statements each time. Is there a way to hide them? Funny you should ask. A computation expression could do that. Here's one that does exactly the same thing. Type logging builder, let p equals blah. Bind to x and f, return this. And we go ahead and create a new logging builder. And then we just do logger. And we go ahead and run this computation expression. Oh man, we got all sorts of YouTube videos dropping in chat here. Let's see, who did this one? Sheffield Hallam University. All right. Now let's check this one out. Aspiring developers since 2008. Logic versus side effects. Functional goodness you don't hear about. Well, thank you. I'll go ahead and add this to my, let's see, watch later list. Go ahead and do that. And I'll do the same for this one too. I'll go ahead and add that to my watch later list. Sounds good. Well, thank you very much. I'm eager to go ahead and learn these patterns. I think they'll help me build my domain a lot more effectively than what I've been trying to go ahead and do with some of the C# stuff. Now, obviously, I've gone and built a whole bunch of services with Akka.NET over the years. And I haven't, how to put this, done this live in front of an audience, obviously. But typically, what I've kind of settled on is doing similar to what I did before, but I didn't have all the C#9 record syntax for doing that. I had to go ahead and write a lot of boilerplate for supporting that. The reason why I'm trying to go through this trouble to learn all this now is I'm hopeful, and so far I feel very encouraged by what I found, that using F# and some of these sort of concepts that are kind of embedded in the F# type system and also its general programming model will help me accomplish
what I've historically done in C# with many fewer lines of code, but also being more type safe in the process. It was when I was writing all those fluent validation classes for trying to go ahead and make sure that all the different entities that comprise my state were all in a valid state before I modified it. That was really where I kind of felt like we need to go ahead and actually build a better model for doing this. You said actors come up in the final chapter here. Okay. Well, now I'm intrigued. Introduction to message passing and concurrency. Need for shared mutable state. The actor model. Okay, there you go. Major actor. Yep. Agent state, chapter 12. Agents. Yep. Getting started with some agents here. I keep scrolling. Agents versus actors. Talk a bit about Akka.net, Orleans. Functional APIs. Oh. Very cool. I've wanted to write a book about Akka.net. But I really want to write a book about Akka.net, but man, it is very tough to find the time to do much of anything. Even writing blog posts is something that takes quite a bit of time these days. But I think it would be helpful if I did. You know, it's just like there is one Akka.net book that actually is written in F#. I've got a copy of it actually. Reactive applications with Akka.net. And this is all written in F#. It's a little old. It's written by Anthony Brown. And he personally gave me a copy of this, which I really enjoy. It's written in C#. Oh, well, he's an F# guy, primarily. Here's to show you, I haven't actually gone through a lot of it. Preparing to use remoting. I think this might have even been written. Got some integrations to Akka.io, Akka.persistence. Man, he did a lot. Oh, he's even got clustering in here. And cluster sharding. Hot damn. Wow. Got your hopes up. Well, if I were going to do an Akka.net book, what would be in it? Well, I'm trying to think basically. So it's like I've got the Akka.net bootcamp, which I wrote, which by the way, we're gonna have to go ahead and just totally modernize that and add a lot more content to it. In particular, I want some stuff on the Akka.net test kit and Akka streams and Akka.net persistence and all that added to it. I've got a whole separate course for clustering that we've already built, but I'd want to go ahead and update some of that, and that should be enough to go ahead and sort of help people get their arms wrapped around the syntax. That's kind of a learn by doing approach, which I think is really, yeah, there you go. That's the link to it. Reactive applications Akka.net. Well, I'll make sure to pass that on to Anthony Rook. I think he'll really appreciate that. Anthony used to work for Isaac Abraham, who runs Compositional IT, and they're one of the really big F# shops out there. They're one of the safe stack people, kind of running the show there, and that's why I assumed it was in F#. But I guess it's a bigger market with C#. If I was going to write an Akka.net book, it probably wouldn't be about the syntax. I think I'd probably want to get into systems architecture with Akka.net, which is what sort of problems does Akka.net actually help you solve? And why is it a good idea to invest in learning Akka.net to, address these different types of problems? And so I would talk in broad strokes about how, let's see, long story short, I would go ahead and talk in broad strokes. I wrote an Akka.net book about traditional software architectures are by far and large, they tend to be very database driven. So their state tends to be centralized. Akka.net succinctly is the title. Is that another book someone else wrote? In fact, I think I've seen that before, actually. Is that an ebook
Akka.net succinctly. Yes. By Zoran. Yeah, okay, I've seen that before. I'll drop a link to that too. We have like, I don't know, some Pluralsight courses that are out there, about a dozen of them, but they're a little old. So we definitely could go ahead and use some new ones on that. Let's see, 121 pages. That's quite a lot. Yeah, I really should get around to writing one. All right. So what would I write about with Akka.net? Let's see. I don't even know what that post is about. Abstraction, intuition, and the monad tutorial fallacy. Okay, this is all my functional programming up here, except for this one. Let's see. That was me taking a look at some stuff on our own website. What would I write about in the Akka.net book? Well, I could definitely talk about design patterns of Akka.net. I would probably talk about how to introduce Akka.net into a pre-existing piece of software. That would be a big one, and reasons why you might want to do that. I'll talk a bit about the industry paradigms that are kind of driving people towards the actor model, namely that if you need a model for building applications that is highly scalable, very low latency. When I say very low latency, I mean we're talking single-digit milliseconds, not hundreds of milliseconds. And you need something that's highly fault tolerant. You basically need a decentralized stateful solution. And the actor model is really the only practical way of doing that. You need to have essentially the ability to partition each unit of state inside its own discrete, uniquely addressed entity. And that entity needs to be capable of managing that state with some strict rules, which the actor model imposes. In particular, the state can only be modified one event at a time, and it can only be modified by default in first in, first out order, in the original order in which those events were received. And anytime you want to receive a copy of that event, it has to be made, basically that event has to be copied into an immutable data structure and passed back. So yeah, talking about interoperability, I guess, basically there's a bit of a dichotomy there between the practical and the theoretical. My default instinct on just, let's say, talking about Akka.net and why you'd want to use it, since that's a big part of our business, I tend to err on the side of the practical. And I think that, but with a bit of moderation on that, because there's a dichotomy. If developers don't understand conceptually what's the benefit of Akka.net, then they don't care about how it gets integrated with the other parts of their system, because that's kind of like a second order question. So you have to address these sort of conceptual candy first. You got to go ahead and give them, here's all the magic stuff you get. But then you also have to go ahead and practically lay out a roadmap that lets you go ahead and say, okay, now that you're interested, here's how you get that. Here's how you go ahead and get the goods that we've promised. And yeah. So self-interest, basically putting it in the developer's self-interest. So obviously Petabridge has an economic incentive to get as many people to use Akka.net as possible. And that's true. But a very small percentage of Akka.net users become paying customers for us. And that's a natural function of an open source business. And you want it that way. You want the technology to go ahead and be open source and also have a very permissive license structure with it. So that way it is risk-free for developers to go ahead and try it. And when I say try it, I mean try it in an actual meaningful context for their business, not just open source toy applications that have no business value. That's the biggest benefit from a commercial standpoint of open source, is it makes the barrier to entry extremely low compared to a proprietary product that has draconian licensing rules and everything around it. That's a big benefit there. The second is you want to build an ecosystem of people who know the open source technology, can list it on their resume as a skill, and actively talk about it on their blogs or YouTube or conferences. And this kind of all helps build value
around the open source technology for everybody, for the developers who know it, for the companies building things on it, for the people who like us who may help maintain it and build and sell services around it. It kind of makes things viral, is what it does. Where writing a book might help is, I think it might help go ahead and make the case for a lot of users. Let's say, here's some real business problems this could solve, and here's why you should take a look at it. It's really kind of about the top of sort of the funnel of users eventually. Is you want to go ahead and essentially say, if you are someone who is a trusted technical advisor inside your organization, when I say trusted technical advisor, it means you're the software developer that your leadership team trusts with big architectural decisions. Probably because you're the developer who is always out there learning new stuff. You're staying on top of what the latest patterns and practices are. You are someone who gets excited about new technologies and likes to bring that to other members of the team. You help improve the skill level of the other people on your team just by virtue of how passionate, knowledgeable, but also generally like helpful you are, right? That's sort of the sort of people we want to reach when we're trying to go ahead and produce blog posts, YouTube videos, and that sort of thing. One of the things we need to help give those people, though, is the ability to go, essentially some roadmap for helping them get the rest of their team aligned on here's how we could actually economically introduce a technology like Akka.net into our business. And it's not something where we have to go ahead and do a giant rewrite, which is high risk for most companies. We can go ahead and introduce it gradually. That'd be the sort of thing that you could address really well in a long form medium like a book, better than a blog post or a YouTube video, because that involves kind of gradually immersing someone in a little bit of conceptual overhead, but also a little bit of practical sort of like, you go from A to B to C to D type stuff. Yeah. Andrew, how are you doing tonight, man? Reply latency. In our app, our web API is able to fire a message to a sharded persistent actor and get an act that's been written to the database using Persistence Journal and SQL Server in about 8 milliseconds. Other teams in our organization wonder how we do it in C#. Man, I know which organization you work for. I'm not going to say it. But man, I wish we could go ahead and get that as a testimonial on the Akka.net website. That would be very impressive. I'll go ahead and give you another testimonial anonymously from one of our customers. Working on it? Well, thank you. I appreciate that. Andrew, who's in chat here, is one of the other main contributors to Akka.net. One of our other customers, they run an airline. We have multiple airlines, by the way, that use Akka.net for this exact use case I'm about to talk about. They have to enable what we would call broad search. Broad search is a brutal problem. Broad search looks like this in the travel industry. So your inventory is highly perishable. Theoretically, you can sell the same seat to multiple people and overbook it, but there's a very finite limit on that. Generally speaking, you really can't. And you definitely can't sell the same hotel room to multiple people. And a lot of airlines make a lot of margin by bundling flights, hotel, and rental car together. Those three form a package. They might also include some things like excursions, like, I don't know, you fly at Disneyland, you get a rental car, you get a hotel room, and maybe you also buy some tickets to see, Disney on Ice or something like that, right? But it's usually the hotel rental car flights. So inventory is highly perishable, meaning it changes frequently. Also means the price gets recomputed frequently. And there's tons of different combinations of origin airports, destination airports, and not to mention times of year, because all the inventory is pinned to a specific flight inventory, of which there's only one flight that takes off at that time, typically. You can have, takes off at that time from that destination airport going to that arrival airport. For maybe some super high throughput like lanes, like going from LA to New York, maybe there's multiple that take off at the same time, but not really. Usually they just upscale you to a larger plane when you do that. Now, a broad search problem involves saying, I want to go ahead and take my family of 4, and I want to go ahead and go from any one of these 4 origin airports that all happen to be pretty close to each other, and I want to go ahead and fly from any one of those 4 airports to any one of these 12 destination airports anytime over the next, let's say, 3 months for under $1,000 per person. And that is what we call broad search, because the number of combinations of all the different destinations, hotels, rental cars, all that sort of stuff is in the tens of millions to hundreds of millions of possible results. In order to go ahead and actually have a high conversion rate, you have to be able to go ahead and basically execute that search and produce, let's say, 100 really good results as fast as possible. The slower you produce it, the lower your conversion rate is. With a system like Akka.net, we've got multiple customers in the airline industry that can do that in under 5 milliseconds. The amount of time it takes JavaScript to render the results is actually greater than the amount of time it takes the Akka.net backend to compute them. So those are some of the big benefits of a technology like Akka.net, is the ability to go ahead and essentially drum latency out of systems. By the way, at least one of those customers in the airline industry tried doing that with Elasticsearch, and they basically melted it. Elastic can't handle that many different, let's say, dimensions to go ahead and work with. So they ended up basically building their own bespoke search using Akka.net behind the scenes. And yeah, we've got at least 3 major airlines that all use Akka.net for doing that exact same thing. So yeah, is what it is. But those are the sorts of things I'd like to talk about a bit more, is how you can use Akka.net to achieve those sorts of benefits, because it shifts the paradigm from this sort of stateless CRUD model to a stateful, low latency, highly decentralized model that's also, from a hardware perspective, linearly scalable. Those are all benefits that be very attractive to a VP of engineering or a really senior director in a software organization, the sort of person who would basically be responsible for owning an entire product. That's ultimately the decision maker who writes the checks that have to go out, and also the one who kind of approves the final decision to move forward with this particular technology strategy. We've always got to be in the business of earning the respect of the people who actually do the implementation. We also need to go ahead and give those people the tools to basically convince their management that what they're doing isn't insane. So that's where having a book would be really helpful. Might be a good long-form way to help arm those champions at Akka.net with persuasive arguments as to why it's worth investing in this conceptually for their business. Now, that was a long but worthwhile tangent. Getting back to computation expressions in F#. This is my Google, it's my Google Translate widget in Brave here. So this little logger function here allows us to go ahead and we get the same output, but this logger function will be applied to all these different expressions. Okay, the light bulb finally went off for me here. H3, if you're still in chat, I think my brain no longer hurts. What this is doing is this binding expression is saying, I want to go ahead and bind this expression to run inside this logging. Basically, I'm going to go ahead, that expression is X. I'm going to go ahead and run that through this function and through the function I'm passing in here. And that allows me to go ahead and compose all those functions together now. And I can go ahead and do that ad infinitum for all of these. And it's this bind operator that basically goes and constructs those together. This is basically like currying in reverse, where we're going and essentially are feeding this function into another one. Oh, and there's the monad. That's the whole monadic stuff, the functional burrito that we're building there. Okay, I think I finally understand that now. H3, are you on the same page? I think it's going off for me. Not 100% there. You got carry out. Hey, no sweat, man. Oh, okay, man, that feels good. Food definitely does help. I grilled a gigantic ribeye tonight. In fact, I had to cut off the gas burner on my grill because I had so much excess fat from the cuts of meat that we were grilling that the entire inside of my barbecue was like a roaring inferno. It got to 600 degrees Fahrenheit for, since we're here in the United States. 600 degrees Fahrenheit, even without any of the burners running. Just from the amount of flames from all the fat that was basically caked at the bottom of my grill burning. I was genuinely worried that I was gonna have to get a fire extinguisher, but it thankfully burned itself out. And hey, my steak had a very nice char on it. So can't complain, even though that was a little terrifying for a second there. All right. Safe division. All right, so we go into safe division. If bottom equals 0, return none. Otherwise, we go ahead and actually do the work. Put it to use. Here's a workflow attempts to divide, starting at number 3 times. All right. Maybe we define a new type. This is basically to go ahead and do our divide by 0 validation for us. Based on, well, actually, no, I guess we're looking at the option type here. All right. Maybe. I see. Okay, no, so the option type is coming from there. Chains of or else tests. Man, the music's been nice tonight. It's been pretty mellow. Here's how this might be used. Multi-lookup a, etc., etc. How can this be simplified? An or else builder. This dot return from X. This dot combine A, B. Some A succeeds, use it. A fails, use B instead. Okay, this gives us the ability to go ahead and have like divergent pipelines now. That's something that we're going to need to do in the course of building this. Okay. This is making me feel a little bit more confident with some of this. Okay. Man, this is how you know this is old. This is old code. This is using the old begin and end pattern, which async await essentially replaced. I know H3 sent me a link on Twitter. They've added a brand new sort of async state machine to F# just this week, which I would love to go and take a look at. That might be a good first-class citizen for maybe potentially replacing some parts of the Akadana API at some point in the future for F#. Because I'm actually thinking about replacing the actual way the dispatching system works in Akka.NET, where rather than it being just, let's say, a set of void functions that all get executed in their own thread context, it would be one big perpetual async await state machine. It's basically using value tasks and it's continually awaiting on the next result until it gets woken up again. That's something I'm thinking about doing in the future in order to make Akka.NET play more nicely with things like async local, which is how OpenTelemetry does things like tracing and that sort of stuff. That's kind of why I'm thinking about that. All right, computation expressions, got it. Okay, starting to figure out how that works. We took a look at continuations. All right. Here's a typical C# code. Return top/bottom. The called function always decides what to do. Implementation device decided it's going to throw an exception. What if I don't want an exception? What if I want a nullable int? Or maybe I can display it on screen as div0. Why throw an exception? Continuation is simply a function you pass another function in order to tell it what to do next. Yeah, that makes sense. Here's our before code, divide top and bottom. So after code, divide if 0, if success, top, bottom. Partial application's cool. That's how you end up building things like loggers in F#. Go ahead and partially apply a function that constructs the logger, and you can pass in that partially applied function to go ahead and actually run the logging statements elsewhere. That's always useful. Let's see. If 0, yep. Take a look at that. Email address a string. Create email address a continuation, success, failure. Using continuations like this leads to a style of programming called continuation passing style, or CPS, where every function is called with an extra what to do next function parameter. Yeah. All right.
how does this all fit in with let? Let's go back and revisit what let actually does. Remember that a non-top level let can never be used in isolation. Must always be part of a larger code block. It is let x equals some expression. Really means let x equals some expression in an expression involving x. I see. And if we pipe the value of x as well, some expression. Okay, wrapping a continuation function. Pipe into some expression lambda. The logging example revisited. Right. Well, I don't necessarily know if this code so far is going to help me. Let's take a look at the builder stuff. Let x equals wrap type value. Look at that. Special builder methods in a builder class. Trace builder. We go ahead and bind. We match m with none. Binding none exiting. Binding with some continuing. Option bind fm return. All right. So we go ahead and do trace. This creates a new trace builder. All right, let's see what this looks like. We'll go ahead and do a new interactive session here. Let's go to, yeah, go ahead and do a new scratch file, fsharp script, and we'll go ahead and, do that. Format string can be replaced by interpolated string. Well, it's the first time any of the automated refactoring in Writer has actually done much for me. That's nice. All right. Make an instance of that. Okay. And then if I go down here, run some code through it, let's see what this looks like. All right, control \. Okay. So this is our tracing code. Returning unwrapped 1 as an option. Okay, nice. Okay, result sum 1. Returning an option sum 2 directly returns sum 2. Right. Okay, building with sum 1, continuing, building with sum 2, continuing, returning an unwrapped 3 as an option. And then returning none. Exiting. Okay, that's very interesting. So what this is doing is each time we go ahead and we run one of these options, we're basically binding the previous trace builder. Yeah, we're going in and essentially are binding this to the previous results. If I go ahead and do let's give this a try. Z equals x plus y. I think that should be all right, right? Maybe not. I go ahead and try running this again. Oh, whoops. Go ahead and do that. Then look at result number 3. Binding with sum 1, sum 2, sum 3. All right. Binding with sum, continuing, option up bind, FM. Okay, so that's how we go ahead and do a bit of a builder. I see where he's going with this now. I see what he means. Okay. Still, not 100% sure where this gets me. Yeah, from an event sourcing point of view, I'm still not 100% sure what the best way to go ahead and model my re-entrant out of order sort of my re-entrant sort of out of order state is. One approach, actually, this is a good idea. One approach I can go ahead and use is I don't actually model. Let me think about this. Maybe I don't actually go ahead and model necessarily my snap. Well, I guess maybe I build my snapshot really as the sum of the parts each and every time, rather than trying to go ahead and modify that snapshot as it's being changed. That's one approach, but I think that's got some problems. Let me think about this. Okay. Here's what I'm going to try to do. I'm going to go ahead and do type created product. It'll be a record. And we will have a, let's see, navigation name. That's mandatory. And then what else do I need in order to create a product initially? I think just a navigation name is what I ultimately need. And then I think I need a product. What was it called again? Publish status. Well, actually, I don't even need this. Publish status doesn't come till later. I know the publish status is. All right. Okay. Created product. We have a navigation name. I think we have some publisher data. And then what else do I have? Let me go ahead and take a look. I think I've dicked around enough with trying to go ahead and figure out how to use some of these F# patterns. Let's go ahead and actually just take a stab at doing something. Make a mistake. Always change it later. Let's see. What do I need? I'm looking at my old protocol that I wrote in C#. I just need a navigation name. And that navigation name has all that good stuff. I guess the next thing I need is I need a product ID. Okay. All right. Let's go do that. Product ID. Yeah, that should be right. Go ahead and open that module. Good. All right, this is our created product. Initial state after receiving a create product. Manage. Type kinded product equals, and here's what I could do. Product kind. Will that work? Yeah. There we go. Just make a little tuple out of those two there. Next, kinded product. All right. Let's see. I'm going to go ahead and Google something real fast. F#
Declaring records with optional properties. I want to know if this is an anti-pattern or not. Looks like it's not. Okay. All right, you know what? I'm going to go ahead and create a type in progress product data. And this is going to be a record type. Go ahead and do this. Let's see. Go ahead and do, let's see, we'll have our, if I go to, get rid of this. In progress product data. Oops. Terms, product terms. Like that. Let's see. That should work fine. We'll have that. I think I need to do an equals here, actually. Equals. And I might need to import the module. Yep. That looks good. Okay. Terms, product terms. Now, if I go ahead and call that an option, that should be all right. I'll go ahead and do a, let's see, description, option, yeah, it should be display text. Tagline, screenshot. Actually, you know what? I need a screenshot is what I need. And I need a, let's see. I think it is screenshot list option. There we go. And then I need, go ahead and move this around actually. Logo. Stored file option. Website. List option. Okay. And I should probably go ahead and create a member here. I should go ahead and do, yeah, let's see. Only classes and struct types may have constructors. I thought I already did this for, if I go to Hines. Type, private. Yeah, maybe not. Maybe that won't work here. That's okay. Static number create. In progress product data. Yeah, let's see. Is there? Do I need to go and specify a return type here? Just give it a hint. 1, 2, 3, 4, 5, 6. We got 6 of them there. How do I provide it with a hint here? Maybe I need to add that to my return method. Make the member static or use the notation. Do I not know? I do not know enough F sharp to be able to do this, apparently. All right, let's go down to write kinds. Static member instance. Yeah. All right. What's the best way to do this? Yeah, how do I go about actually creating one of these? Equals none. Let's see, what if I did some... Oh, derp. That's what I'm doing wrong. Well, one of the things I'm doing wrong, at least. Initiate record type with hint. Let's see, how do I go ahead and provide a little hint here on what record type it is trying to instantiate? Yep. Oh, well, that would do it. If I go ahead and assign the property names, that should help. Okay. Yeah, if I go ahead and say, all right, terms equals none. Description. Let's see. Tagline. Logo is none. Screenshots. Okay, now we're in business. Fantastic. So I can go ahead and create a default non-populated member. Whoop, don't need that. All right, that looks good. So I can go create some in-progress product data. Great. I can have another type here. Type publishable product data. And that'll go ahead and be all of these, but with no options. Get rid of that. Perfect. Type publishable product data. All right, that's fantastic. And then I can go ahead and add a member or a function to go ahead and turn this into publishable product data. Product display data that is fit for publication. Okay, I think this is all right. So in terms of handling the out of order stuff, I think having option types here is probably the way to go. And I can use that sort of, let's say, those continuation functions we're looking at
I could actually go ahead and use those to like iteratively validate all the different fields inside of here to go ahead and make sure that the options are actually really populated. So that's something that we could go ahead and do. That should help. Now, in terms of representing our product states, we've got our in-progress product data, we've got our publishable product data, and then I need to go ahead and create a data structure for fulfillment. So let's go ahead and do I have a fulfillment request type at all anywhere right now? Don't think I do. Let me go ahead and create that. Yeah, let's go ahead and add this to our Sdkbin.product.abstractions. Let's go ahead and create in here. We'll go ahead and add a file for fulfillment. I think I'm spelling it right. Yeah, we're going to do that. We'll go ahead, this namespace, module, fulfillment, import, and I'll go ahead and create a type here. We will go ahead and do a, let's see, creates a customer-facing fulfillment request. I'm looking at some of my old C# types, and I'm not totally sold on having to do, not totally sold on having to do any of these sort of publisher-facing operations with generics. I think we can get away from that because that's kind of the actors that own the fulfillment system are going to run the show there. Uh-oh. How are you doing, buddy? Sorry, we got a little visit from the Pettibridge mascot here. Do you want to appear on the stream? Want to say hello to everybody? He's not sure. He's feeling a little shy after he got a haircut this week. All right, bud. You want to show everybody your haircut? No? You just want me to rub your belly? All right, I can do that. All right. Well, I think it's kind of the rule of any sort of streaming etiquette. I've got to go ahead and show the pet when he comes walking in. All right, come on, buddy. Come on over here. All right. Oh, here we go. All right. Yep, here we go. This is Ardbeg. Hopefully you all can see him. Let me go ahead and adjust the webcam a little bit. He's my buddy. He likes hopping up on my desk. Yeah, this is the cat. That's right. He likes hopping up on my desk and lying on my keyboard while I'm programming during the day. But when he's usually he's sleeping quite a bit. He'll go ahead and occasionally dig his claws into my leg and let me know he's ready for some rubs, which is what he was doing just now. Yeah. All right, buddy. I'll go ahead and let you down. Yeah. So he's my little four-legged coworker. He's usually pretty well behaved. All right. Well, I'll go ahead and he is a big boy. He's a rescue cat. We got him from the Houston SPCA, I guess, a couple years ago, just about. And so when we got him, they had told us that he was definitely someone's pet before because he'd been neutered. So definitely he was someone else's pet. But they told us that they had found him like eating trash out of a dumpster and he had to have some surgery on his teeth and everything. But this cat was definitely not abused. He is super duper friendly, loves getting belly rubs, follows me around, follows my wife around everywhere. Very friendly. The thing that was kind of funny was we thought he was a short-haired cat. Nope, he's got some Persian in him. He has a super fluffy coat a lot of the time. So we get him shaved about twice a year because his hair gets a little overgrown and he starts getting food and other stuff stuck in it. Plus, it's really hot in Texas right now. So we thought he might be more comfortable with the haircut. Plus, he looks cute. My wife likes it. And his name is Ardbeg, after the Islay Scotch that I enjoy drinking so much. So that's his name. And he's the little unofficial Pettibridge mascot. And I miss him terribly when I have to work from the office. But when I'm working from home, I get to go ahead and play with him. All right. So last thing I'll go ahead and work on.
is my fulfillment request data type. So I'll go ahead and do type, fulfillment request, and we'll go ahead and say we have a product ID. I'll do type, fulfillment, request ID equals single union, or sorry, a single case union type there. Well, don't need to do that. What I need to open is, let's see, open Sdkbin.common. Yeah, he's a very big boy, that cat. He, the doctors chided us after we got him because he put on so much weight. So within like his first 3 months of living with us, that he was going to get diabetes unless we started putting him on portion control, which we have an automated cat feeder now that basically meters out only a specifically prescribed portion of food. But that little guy does not miss meals. And I shouldn't even call him a little guy. He's kind of a porker, to be honest, but we love him. And no, he's not that fat, but still, that cat will definitely do some damage in terms of caloric intake if we don't pay attention. Let's see. All right, got that. Actually, let me go ahead and space this out to make it a little bit more readable. Do this. I guess I don't need... Oh, cool. Writer automatically got rid of the semicolons for me. Well, that was nice. We'll go ahead and do message, play text, and then... Yeah, I think for the time being, I think that's probably all I need. Now, how do I implement... Let's see. Let me go ahead and go to implementations. Oh, that's a bummer. Where do I use I with product ID? Create product. Don't use it there. Maybe my user activity protocol. Do interface I with user ID. Okay. Here we go. Let's go ahead and do I with product ID. This dot product ID equals this dot. Okay, there we go. That should implement that interface. And I'll go ahead and rename this actually to, let's see, start fulfillment request. And then, yeah, it's a fulfillment request. And then I'll go ahead and do type complete fulfillment request. Yeah, go ahead and do add both of those. Actually, maybe this is a better way of doing it. Let's see, fulfillment status started. Completed. Gonna do a little enum here. All right, and then we'll go ahead and do that. There we go. Perfect. All right, that should go ahead and allow us to get away with using just a single type here.
Okay. That looks good. I got my publishable product data. And so, publishable product data. All right. And then I'm going to need to go ahead and add some types for describing like valid pricing and that sort of stuff. But I think we're out of time for tonight here. So everybody, I've had a fantastic time working on some of this F# stuff. I always, as usual, really enjoy interacting with everyone in chat. That's my favorite part about doing all this. I'm going to go ahead and pick up where we left off on Thursday night this week. So thank you very much for your time. I hope you found this entertaining. If there's anything we can do to make the stream better for you, please go ahead and let us know. You can always reach out to me on Twitter. My DMs are open. I'm Aaron on the web on Twitter. Or you can always let me know in the comments here. But thank you very much for your time tonight. And I hope all of you have a great time. So thank you very much. And I'll see you on Thursday. Take care, everybody. And until next time.